Okay, so back to our donut example, and this time we want to talk about rotation or orientation of our sprinkles. Now, for this to make a bit more sense, we will not work with spheres, but we will work with little, actually sprinkles that are stretched a little bit. Those, they're more like tubes or something. So let's use those instead, and then it looks like this. They're weirdly not aligned, they just stand up straight. So how can we change that? To understand this a little bit better, let's have a look at a simpler example so that we can follow the logic a little bit more. So what I have here is just a cone, and this is based on the Platonic node, which I set to tetrahedron, and then give it some color, match size, scale it down a little bit, and let's now copy this onto this sphere. So we will scatter some points first. Let's turn off the background for now. And then with the copy to points, of course, we will copy this on. So this time I use the right sides. The input is on the right and the geometry that we copy is on the left. And what we get is this. Actually, let's add a bit fewer points so that we can see that. And this is what happens, just like we saw. If we merge the two, the sphere and the cones, it makes a bit more sense. You can see that the cones stay upright, but of course what we would probably expect is that the cones are aligned along the surface, so like spikes that they look outwards. How can we do this? Well, by default, if we would actually use the sphere itself that we already have, and actually let's lower the resolution a little bit so that we have fewer points, and maybe you've tried that already, you will see that actually this happens. When we look through, you can see there is some alignment. Let's make them a bit smaller actually. There you go. You can see there is some alignment, and that is because by default the copy to points is interpreting the normals for the orientation of our spikes. Now, before we talk about the fact that they are not aligned like we expected with a top spike outwards, let's first talk about why this is not working when we use a scatter instead. So if we scatter points onto our sphere, then there's no alignment anymore. We lose the alignment. And that is because by default, it uses the normal of the point input to align the objects. Now, the sphere by default has kind of magic invisible normals, even though there is no normal attribute. For a geometry, those normals will kind of be calculated automatically, and this is why they will align properly. As soon as we use points though, this normal is completely missing and it cannot be calculated anymore because a point has basically no concept of forward. So we need a normal attribute actually for this to work. And the simplest way of doing this is using a normal node. Now be careful, if you put this after the points, the normal node will create normals actually, by the way, by default on the vertices, but in our case, let's actually switch that to points because it makes more sense. And you can see here there is now a normal attribute, but it's all set to 0. So this is not working. You cannot create a normal from just points because the normal node needs a surface to calculate the direction. So whenever you want to calculate a normal for points, do that if you scatter them before you scatter the points, because then it takes the normals of the sphere, of course, and you can see this actually works. And as soon as you scatter onto that sphere that has the normal attribute, the points will inherit that normal attribute. So this way now our points have a normal attribute. And this means the copy to points will now align our tetrahedrons or our cones as well. But it's still not aligned the way we expected. We expected that when our cone here is pointing upwards, because for our human brain this is forward basically, that this will be aligned outwards of our sphere as well, but that's not the case. Because what's happening here is that the copy to points will always align the z-axis of our object. So this would be in our case this axis. It's a bit weird why that is. Basically the local space of a point is defined by z. The direction of the normal is the z direction. That's, by the way, also true for cameras. The direction you're looking relative to the camera is the z direction. But it doesn't matter. It's more technical reasons. Just remember that your object has to point in the z direction. Why doesn't matter. So how can we do this? It's actually quite simple. You just use another transform node, and now you could just play around until you find the axis that you need to point your whatever you consider as a forward in the z direction. And actually the trick here is it's actually always the same, and that is 90 degrees on x. So when I do this, I don't have to think about this anymore. I always drop a transform node, rotate x in 90 degrees, and it's almost always correct. So you don't have to think about this every single time. Just put in 90 in x and you will be correct. And now when we look at the result, you can see this is actually what we expected. our cones are pointing outwards. So great, so let's do this actually with our donut example. So we can use the normal node, of course, before the scatter node, and this will calculate the normal based on our geometry. And currently the normal is creating it on the vertices, the normal, which still works for a couple of versions now. The scatter node will understand that and move the normal attribute over to the points. But just to be safe, I still have the tendency to create the normal on the points just to be safe. And we can see now that our sprinkles are actually aligned on the surface of our donut, but just in a weird way. And that is because of a very important concept. As you can see, it's not enough to give an object just one normal to get a clear orientation. You always have to give it two vectors, and that is n and up. Now let me quickly talk about why that is. A good example of explaining this is if you wanted to tell me how to orient myself to you. You would say, okay, Christian, orient your head towards the ceiling. Okay, so that I stand upright and not sideways or something. But that's actually not enough if you would tell me that, because that would still be true for this orientation, but it will also be true for this orientation, or for this orientation, and also for this orientation. So just giving me one vector is not enough. You have to give me at least two. So you could say, point your head towards the ceiling, but your eyes should point towards the camera. And then there's only this orientation that is absolutely clear, and there's only one possible solution for this. And the same is true, not just for your instructor, but also for your sprinkles. So to solve this, we need a second vector, and this is usually called the up vector. Because we can see that our sprinkles are aligned to the surface, but we would want them to rotate around that normal that it's aligned to in a random fashion. So let's create an up vector, and first, just to show you that this actually works, let's do this with a point wrangle, and we just create this vector ourselves. It's a vector, so let's call it up, and then let's align this to, let's say, the x direction, so 1, 0, 0. And when I press Ctrl Enter, you can see now that all the sprinkles are still aligned towards the surface, but they're also aligned in the x direction. So this is not what we want, but I just wanted to show you that this up vector actually works. Let's quickly visualize that. And I've already prepared this here. Well, almost. So the yellow vector is our up vector and the blue vector is our normal. So together they can define a clear rotation. But instead of setting the up vector ourselves, let's actually create a random up vector with the attribute randomize. So we want to randomize the up vector. By default, it creates a vector anyway, so this is working. And now when we look through it, we can see this actually created a random rotation. Now it looks a little bit odd, and that is because of something that we will talk about later when we talk about randomization and noise. We actually currently do not create a random rotation for up in 360 degrees, but only in 180 degrees. And that's because here the values are from 0 to 1, but they actually should be from -1 to 1 for this to work. And now you can see it looks much better. We will talk about this in a later video, just keep that in mind. An alternative to this would be, by the way, to just set this to direction or orientation, and then it will create a 360 degree random rotation anyway. We will talk about this in the randomize and noise videos. And now you can see this is actually what we wanted. And again, let's have a look at our vectors so that we understand this a little bit better. And here you can see now every point has a random up direction and the blue n direction defining the main direction on the surface. Now, a lot of students ask me, okay, I get that. So now we have random directions, but how could I change this rotation or maybe animate it? There are multiple ways of doing this. For example, in the Vex chapter, we will talk about matrix multiplication, but as you can already hear, this is kind of complicated. The easiest way of doing this is a node we will talk about later called the attribute adjust vector node. We'll talk about the attribute adjust nodes, but you know, the name explains what it's doing. It's adjusting a vector. And the vector we have already, we want to change, is called the up vector. And what we want to do is we want to rotate it. Unfortunately, the function only works when you set it to direction only. Don't ask me why. And then under operation, you will find the rotate function. And here now you can rotate the up vector around a vector of your choice. Currently, that's in direction of x. So if you would rotate this now, you can see it seems to work, but some sprinkles are not rotating properly. They all rotate in a different speed. And that's because they all rotate around a weird angle. If you visualize that, we can kind of see that we actually rotate around the x vector, which is not what we want. We want to rotate around the normal. And we can do this by just setting this instead of a manual vector to from attribute. And this is already by default set to n. And now all the up vectors will rotate around the normal. So this is an easy way to rotate a vector around another vector. And then the result is this, which is much more what we want, because now they all rotate in the same speed, because they all rotate around their own normal vector. This again could be a way to adjust your rotation or maybe to animate the whole thing. Of course, not for this example, but maybe for other cases. Okay, so now this, in my opinion, is the most important concept to understand, the n plus up vector concept. But there is another way that you will often see on the internet, especially when you work with vecs. You will find this a lot, and that is instead of using two vectors, we just use one attribute, and that is called orient. Now the orient attribute is a bit odd. To show this, let's just turn off all our vectors. So we have no vectors anymore. And with an attribute randomize, we just create an orient attribute. And you can see nothing happens, even though this is the correct name. And the reason is that the orient is a very weird mathematical concept. It's a quaternion, which means it actually consists of 4 dimensions. Now, this is something that's very confusing. It's basically just a mathematical way of defining a rotation in space by using 4 dimensions. If you think, how can I imagine that? You can't. It's not how a human brain works. So it's a purely abstract concept. Usually what you use orient for is either as a helping mechanism, which you can see in vecs at some point, or we can use it here as a way of just create completely random directions. It's not meant to define specific rotations though. So the reason it's not working is that it has 4 dimensions, and this is why we have to change the dimensions to 4. And now you can see it suddenly works. And this is, by the way, the reason, if you ever wondered why we need 4 dimensions, it's for stuff like the orient quaternion. Now in our case here, this doesn't actually really work, because now all the sprinkles are completely random. They don't follow the surface anymore. So this is why I showed this to you at the end. This can be helpful in some cases, but in most cases, the n plus up vector concept is much, much better in my opinion. But I just wanted to make sure that we talked about the orient. By the way, I linked a video on YouTube that tries to explain what a quaternion is. It's pretty complicated and confusing. So if you don't fully understand it, that's actually fine, because most FXDDs couldn't explain to you how a quaternion works. They just know that it exists and what it's used for, and most of the time it's used for completely random rotation. Let us leave it at that. If you're interested in that topic, feel free to Google more about this, but for most cases, this is all you need to know about the orient attribute. So let's turn this off, because in our case that doesn't really work. We instead use n and up, which I would recommend for most cases. Now to finish this off, just to be clear, this was just one example, in my opinion, to better understand it. But of course you would use this for other stuff as well. A very common case for this is landscapes and scattering geometry on landscapes. And here is a setup that I quickly want to go through with you. So what I did here is we have 3 different things. We have fawns or grass, we have rocks, and we have trees. And they all need a little bit of a different logic, because for example, our trees, they point, as you can see, all upwards, of course. They are not rotated along the surface, but at the same time, when we look from the top, they are all rotated differently around that normal. On the other hand, the rocks, for example, are aligned to the surface, as you can see here, and then on top rotated around this as well. So how did we do this? Let's have a look at the rocks first. By the way, we created the rocks with our good old mountain node, just like we looked at in the mountain video. And then you can see here, we scattered randomly, and we all give it a random p-scale. That's easy to understand. So we don't use the scale for 3 directions, but actually just p-scale for the whole thing. Then we give it random colors. I use the attribute adjust color for that to give it different, gray variations. And the orientation is built based on the normal that we got from the surface. So on the points is a normal that looks like that. So in this regard, the rocks are actually aligned towards that n. So it would look like this without the up vector. And then I add an attribute randomize for the up vector to rotate them around that vector again. And I use the direction orientation in the attribute randomize. And this way I have rocks that are aligned to our surface based on the normal, but at the same time rotate it around that normal based on a random up vector. Now the trees are a little bit different. Here are our trees, and as we've seen, I already rotated them so that the top is aimed toward our Z direction. And the special thing here is that I want them to rotate around the normal, but the normal should be upright. And you might already guess how to do this. We just have to make sure that we create our own normal. And I do this with a simple VEX code. N equals set 0, 1, 0. So our N, when we look at it, is just pointing upwards. So we control the N ourselves. We do not have to use the normal node to create the N. We can just set it ourselves so that we can make sure it's pointing upwards. But on top, we use an attribute randomize. And then what we get are the trees pointing upwards, but around themselves, they are rotated randomly. And in the same way, I worked with the grass pointing towards Z, and then I use an N pointing upwards, but a random up around that, so that we get a grass that is always pointing upwards, but is rotated randomly around that N vector. And by merging all of this together, of course, I get a landscape with different elements. So it depends what you want. That's what I wanted to show you. It's not always the same technique. Sometimes you want to set your vector specifically, like for our trees, for example. Okay, so much about N and up and orient. So how to rotate objects when we copy them. Hope this is helpful. So thanks very much and see you later. Cheers.